Hi again. In the last video I showed you the control of a servo drive with a PLC. But there are cases when a PLC is not available, which is why I will show you one way to control the servo drive without a PLC. Instead, I will access the drive using Modbus and NodeRed, running in a Raspberry Pi. I will refer constantly to the last video in order to avoid explaining the same things over and over again. So if you don't understand something or want to know more details of what I'm saying, please go back and watch the previous video first. This is the hardware that I will use. It is the same one I used in the previous video. I only replaced the Festo PLC with a Raspberry Pi. And I added an Ethernet switch where I connected my computer. Regarding the servo drive, I will use the same configuration from last video. I will now connect the Raspberry Pi to the switch and also the fieldbus cable from the drive to the switch. Now I open the VNC viewer in order to access the Raspberry Pi. I connect to the Raspberry Pi and I start NodeRed. If I go to the top of this window, I can see an address. This is the IP address of the Raspberry Pi, and the number 1880 is used as the port to access the NodeRed editor. Now I open a browser and copy this address. And this is how the NodeRed editor looks like. If you remember in the last video, while configuring the Modbus slave in Codesys, I added a channel in order to send and receive information through Modbus. I will do the same in NodeRed. For this, I need a node called Modbus-Read. I will call this node read Modbus inputs. FC is the function code. I used in Codesys the function code 23. This is not available here, therefore I will choose the code 3. Address is 100, quantity is 12 words, and poll rate is 100 milliseconds. Now I'll click on server to add a Modbus client, which is the servo drive. Type TCP is correct. In host, I write the IP address of the drive that I configured for Modbus in the previous video. I click on add, done. I will copy and paste this node and do the same for the outputs. In this case, the address is 0 and the rest stays the same. In order to see the actual values of Modbus, I need a node called debug. So I'm going to name this node inputs. And I add another for the outputs. I connect them. Finally, I click on deploy. I can see that I'm connected to the servo drive by this green symbol. And now by clicking on debug messages, and by clicking here, I can monitor the inputs from Modbus. I can stop this in order to take a closer look at each word. These are the 12 input words from Modbus. and these, the output words from Modbus. These are all 0 because I'm not sending anything. Once I can communicate with my servo drive, I will now send commands to control the motor. In order to start the motor, I only need 3 output words. So I'm going to add 3 Modbus-Write nodes. I will use the first node for word 0. I will use, in this case, the function code 6, address 0. The second node for word 1, address 1. And the third node for the word number 4, which is the override. Done. Now I need to write a value to each of these words, which is why I need the inject node. For the override, I will use this value. Word 1 corresponds to the record number. Here I can specify the record number. The value could be 1 or 2. And word 0 could have several values. I will pause the video and add the values. I'm now finished, and I only need to click on deploy and test if it works. So first I need to write the override value and the record number. I click to acknowledge to quit any errors and set the initial status of the drive. Then I click on enable. Now I hear the motor being active, and I click on execute. And as you can see, it works. And that was it. I hope everything was clear and easy to understand. Thanks for watching, and have a good one. Bye.